Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where today we are solving the May-June 2025 paper for Physics 0625 extended version, and currently we are going to be doing the variant P21. Okay, so let's start. But before we start, kindly like and subscribe the channel, and if you like anything helpful in the video, kindly remember me in your prayers. Thank you. So let's begin. Question number 1. The speed time graph for a racing car is divided into 4 sections P, Q, R, and S. The car starts the race but soon crashes into walls of tires. Which section of the graph shows that there is an acceleration that is changing? Acha. This is a speed time graph, and if you look at the graph, we know that a straight line graph basically shows a constant speed with no acceleration. So wherever there is an acceleration, there are curves. So if we look at this point P, this is straight line. So there is no acceleration happening over here. The body is moving with a constant speed. Okay. And then if we see this, then there is a curve. So here there was a change in the speed, and the graph was increasing, so there was acceleration. And then over here again, this somewhat became straight, and then at R again you can see that there is a curve, and at S again it's straight line going down. Okay, so the places that are shown on the graph, your sections on the graph that show that there is acceleration that is changing would be Q and R. So C is going to be our correct option for that. Okay, moving on to our question number 2. Question number 2. The diagram shows the 4 forces acting on an aircraft in flight. Which arrow shows the direction of the resultant of all the 4 forces? Acha ji, these are the arrows. Acha, we know that in order, we have 4 forces over here, but we can reduce these 4 forces into 2 by finding the resultant of these forces. Okay, how can we find the resultant? We can subtract one from the other to give the resultant forces that are acting on the aircraft. So these 2 forces can be subtracted, so they would give us 20 kilonewtons in east direction, and then these 2 forces are going to give us 120 kilonewton minus 60 kilonewtons as to be 60 kilonewtons in the north direction. Okay, and there are 2 ways in which we can add the vectors. One is head to tail. Let me write it again. One is head to tail rules. That's how vectors can be added, or the other is the parallelogram method. Okay. But for both of these methods to work, we first need a scale. Okay. So if we say that 1 centimeter is equal to 10 kilonewtons, so 60 kilonewtons would be 6 centimeters, and 20 kilonewtons would be 2 centimeters. Okay, so let's draw these lines. Let me draw these lines for you, and then I'll just be back. Okay, so this is a 6 centimeter line. Okay, and we know that we will going to be having a head over here since it's moving in this direction, and then we have this 2 centimeter line. So this vector has to be over here connected to the head. And then there is going to be a resultant vector from, there's going to be a vector which is going to be from the tail of the first vector to the head of the second vector. Okay, so this is the head to tail method to add vectors. ठीक हो गया? So we have our resultant vector over here, and if we see, though it resembles the option B over here. ठीक है? And if we need to add these by the parallelogram method, so what are we going to do? We have a 6 centimeter line over here, and we are going to have a 2 centimeter line over here. Then again, a 6 centimeter line over here, and a 2 centimeter line over here. Okay, and the resultant vector is going to be from this end to this edge, and you can already see that it also resembles the vector over here. But if you want to confirm which option is correct, you want to be very sure that it's not A and it's B, so what you can do is you can always find this angle. Okay, you can always find this angle. If you are looking for this angle, so you know that this is going to be your perpendicular and this is going to be your base. Your perpendicular is 6 centimeters and your base is 2 centimeters. So you can always use tan theta is equal to perpendicular over base. Tan theta is equal to perpendicular is going to be 60 and base is going to be 20. So this is going to give us answer of 3, and tan inverse 3 is equal to theta. So the angle would be 77.8, I think. Okay. So if you see that this angle is like close to 77.8. So B is going to be our correct option. Okay. So this is a confirmed answer that your answer is B and not A. Okay. Okay. Question number 3. The diagrams show two metal boxes X, Y, extended from identical force meters. X and Y have identical dimensions. Acha. So X and Y have identical dimensions. This means that this side is equal to this side and this side is equal to this side, and this is also going to be equal for them. Okay. But if you look at the scales, so over here one scale points at 2 and one scale points at 3, so it means that they have different weights. Okay. So if we look at the options, which statement about X and Y is correct? They have different volumes and different weights. No, they have same volumes but different weights, because they've mentioned in the question that the dimensions are similar. So they have different volumes and equal weights. This is also wrong. They have equal volumes and equal weights. The weights are not equal. You can see that over here the scale is pointing at 2 and over here the scale is pointing at 3. The weights are not equal. Their volumes, they have equal volumes and different weights. This option is correct because weights are different, and as the dimensions are the same, so volume is going to be same. Question number 4. A girl has a gold necklace. Which apparatus does she need to find the density of the gold? Okay, we know that density is equal to mass over volume. So she needs something that can measure the mass and something that can measure the volume. Now the mass can be measured by a balance, so she requires a balance. The other thing is measuring cylinder. Since the necklace is an irregularly shaped object, so its volume can be measured using a measuring cylinder as opposed to a ruler. A ruler is going to measure the volume of something which has regular shape. Okay. So she is going to need a measuring cylinder and balance. So C is going to be our correct answer, since thermometer is not required and the object is not regularly shaped. So ruler cannot be used as well. Okay. Question number 5. A spring has a length of 25 centimeter when a load of 2 newtons is suspended from it. A spring has a length of 35 centimeter when a 7 newton load is used. So what is the spring constant of the spring? अच्छा, spring constant का हमें पता है कि force is directly proportional to the extension, and then in order to get rid of this proportionality sign, we have this. Okay, so this is the equation used to find the spring constant, but we have two values over here. So what we are going to do is that we are going to take our load to be 7 minus 2 newtons, which is going to give us 5 newtons, and we are going to take our extension by subtracting 35 and 25 and taking as 10 centimeters. So our force or weight is 5 newtons over here, and our extension is 10 over here. So 5 divided by 10 is going to give us a spring constant of 0.5 Newton per centimeter. So do we have such an option? Yes, B is an option that is available over here. There are small things that you have to do in these questions. Don't get confused. 6. The diagrams E to H show a block of wood on a frictionless surface. In each diagram, the block has two forces acting on its sides. Which diagram shows the block in equilibrium? Okay, if we have to find something which is in equilibrium, there are two rules for that. The resultant forces acting on it should be 0, and the resultant moment acting on it should be 0 as well. Okay, so if we look at this option, this is going to let it move in this direction, and this is going to let it move in this direction. So the resultant forces might be 0, but the resultant moment is not 0, because these are two forces in the of equal magnitude and in opposite direction, so they can be cancelled out, but this moment is not 0. Acha, if we look over here, so there is a force of 2 newtons in this direction, and then there is a force of 2 newtons in this direction. So over here the resultant moment is 0, but the resultant forces, because there are two forces acting of different magnitudes acting in the same direction, so the resultant force over here is going to be 4 Newton. So both conditions have to be met, and one condition is not being met over here. Acha, if we look at this option, so these are two forces in of equal magnitude but acting in the opposite direction, so they are going to be cut. So resultant force is going to be 0, and since they are acting in the same line, so resultant moment is going to be 0 as well, because they are in the same line. Okay, so they are going to cancel each other's effect. And over here again, the two forces are acting in the same line, and one is acting in this direction and the other is acting in the this direction. So they are forces of equal magnitude acting in the opposite direction. So resultant force over here is 0, and moment over here is 0 as well. So G and H are two blocks that would be in equilibrium. So D is going to be our correct option. Okay, moving on to question number 7. Which statement is not correct? Okay, the moment of a system is conserved in all interaction. Yes, this is correct according to the law of conservation of momentum. ठीक हो गया? And for B, impulse is equal to change of momentum. I is equal to delta P. This is correct as well. Force acting is equal to change of momentum into time. Nahin. The force is delta P over T. So basically it is rate of change of momentum. ठीक है? So multiplication नहीं हो रही, division हो रही है. So C is something which is not correct. The fourth one states momentum is equal to mass and velocity. So this is also correct. Okay, question number 8. A force acting on a moving ball causes its motion to change. This force stays constant. Okay. What makes the force produce a greater change in the motion of the ball? So F is equal to MA. If this force is not changing, something out of these has to change. So let's look at the option. Decreasing the total mass of the ball. Yes, this is a good option. Increasing the temperature of the ball. Temperature has nothing to do with force, its motion and acceleration. So this is not going to work. Using a ball with a hollow center but with the same mass. If the mass is not being changed, so there is going to be no change. Either the mass has to change or the acceleration has to change. Using a different material for the ball so that it has a lower density but the same mass. If the mass is the same, so nothing is going to be changing. So this is not correct, and A is going to be the correct answer, where the total mass of the ball is being decreased. And if the force produced had to be lesser, so the mass had to be increased. Okay? Or there should have been a change in acceleration. Question number 9. A farmer has two carts. The cart has the same weight, but one has 4 narrow wheels and the other has 4 wide wheels. Which cart wheels sink less into soft ground, and what is the reason? Acha. Over here we are talking about pressure. So pressure is equal to force over area. So pressure is inversely proportional to the area. They want something that should sink less. That means it should apply less pressure on the soft ground. Okay? So if the area is going to be more, the pressure is going to be less. So this wide wheel is going to work because it has a greater area, so it will exert less pressure. Okay? Since they are inversely proportional. So the cart wheel has to be wide, and the reason is that it will produce less pressure on the ground. Okay. Question number 10. A hot gas and a cool liquid are at the same pressure. Okay. Which row describes the separation and the motion of the particles of a hot gas compared to those of a cool liquid? Achha, when the gas is going to be hot, so obviously its particles will have more kinetic energy than that of liquid, cool liquid. So what is going to happen is that separation of the gas particles is going to be much more than that of a cool liquid. Okay, these two options are there, and the motion of the gas particles is going to be faster than a cool liquid, obviously, because of this kinetic energy. So 10 ka option A is correct. Moving on to question number 11. A fixed mass of gas has a volume of 1.2 meter cubes and is at a pressure of 200 kilopascals. The gas expands at a constant temperature to a volume of 1.8 meter cubes. What is the new pressure of the gas? So let's apply our Boyle's law over here. P1 V1 is equal to P2 V2. All of these are in the same unit. So pressure 1 is 200 kilopascals and the volume 1 is 1.2 meter cubes, and P2 we have to find, and V2 is 1.8. So after the solution we are going to get pressure of 133.3 kilopascals. So I think B is going to be our correct option for that. Okay. Moving to question number 12. The specific heat capacity of solid P is greater than solid Q. What does this statement mean? Acha, if some substance has more specific heat capacity, it means that it takes more time and heat to heat up, and then takes more time to slow down, more time to cool down as well than the one thing that has lesser specific heat capacity. Okay. So when P is greater, so it's going to require more energy and more time. Okay. So less energy is required to raise the temperature of 1 degree C of unit mass of solid P. No, more energy is going to be required. So less energy options are going to be cancelled. So more energy is required to raise the temperature by 1 degree of unit mass of P than unit mass of Q. So yes, 12 का correct answer is C. Okay? Because this has more specific heat capacity, it needs more energy to heat up, and then it requires more time to cool down as well. Acha, 13. When water vapors, water evaporates, what escapes from the surface of the water? Basically, individual molecules are the ones that escape, not individual atoms, not individual protons, not tiny drops of water. Okay, moving on. Question number 14. A sealed container of a gas is heated. The pressure of the gas increases. Which statement explains this increase in pressure? Okay, A. The forces of the gas particles striking the wall of the container increases. नहीं, the forces नहीं increase, the succession rate increases. ठीक है, due to them striking the walls of the container more frequently, the force increases. ठीक है, the force of attraction between the gas particles and the walls of the container increase. No, this is not a true depiction. Basically, what happens is that the gas particles basically gain heat, and the kinetic energy increases, and they strike the walls of the container more frequently than before, and this produces more force on the walls of the container. Okay, so this is also not true. The gas particles collide with each other more frequently. Obviously, when they have more kinetic energy, they are moving with more energy, so they are going to collide with the walls more, they are going to collide with each other more. So C is our correct answer. The gas particles lose more energy. No, when it is heated, they don't lose energy, they gain energy. So that is why C is correct option. Question number 15. A student has a copper rod and a wooden rod. Both rods have the same dimensions. The student puts one end of each rod into a beaker of crushed ice. After a few minutes, the student picks up the rods by the ends, not in the ice. Which statement is correct? The copper rod feels colder than the wooden rod because copper is a better conductor than wood. Yes, that is true, because a copper rod and wooden rod is solid, so conduction is the thing that is going to be happening in between them. So that is true. The copper rod feels warmer. No, if it is dipped into crushed ice, so it is not going to feel warmer. The wooden rod is not going to feel colder than the copper rod because copper is a good conductor of heat and cold as opposed to wood. The wooden rod feels warmer. No, this is also not correct. So A is our correct option. Okay. Question number 16. The diagram shows a black object S at a constant temperature. The arrow represents the absorption and emission of the thermal radiation at the surface. Object Y is at the same constant temperature at X and is identical except it has a white surface. Now we all know that black surfaces are good for emission and are good as absorbers, and white substances are not good at absorption and emission as well. Okay, so color matters. So the rate of absorption of X would be higher and rate of emission of X would be higher as well. So A is going to be correct answer, as opposed to obviously the white surface. Okay, moving on to question number 17. The diagram shows a cork with a weight attached so that the cork floats upright in water. Okay. A transverse wave travels across the water from X to Y. In which direction do the waves make the cork move? A, right and left, B, up and down, C, only to the right and only to the left. Okay. Transverse waves are the waves that have particles that move perpendicular to the direction of the movement of the waves. Okay. So the wave is going to move like this. Okay. And we should always remember the fact that waves transfer energy without transferring matter. Okay, so the direction of the cork would just be up and down when this wave passes. The wave is not going to transfer the matter, it is just going to transfer energy. So B is going to be our correct option for this because of the logic I've just presented. ठीक हो गया? 18. A thin converging lens is used as a magnifying glass. How does the image compare to the object? Obviously, if something is being magnified, the image is going to be enlarged. And the properties of the image formed by thin converging lens used as a magnifying glass are that it's virtual, it is upright, is on the same sides as that of the object, and enlarged as well. So these are the properties. So let's see. How does the image compare to the object? It is real and inverted. No, it's not real. Real and upright is also not correct. Virtual and inverted is not correct. Virtual and upright is correct. Okay. Moving on to question number 19. The diagram shows two plane mirrors at 90 degrees to each other. A ray of light is incident on one of the mirrors. The ray reflects off both mirrors before reaching a screen. At which labeled point does the ray reach the screen? Okay, now I've already solved this question for you. I've marked all the lines. So you see that I don't have a protector in this software at the moment. So firstly, this was the normal line. This was the incident ray, and I kept a protector over here. And let's change the color of the lines that I've drawn, and from the one that were already there in the exam question. Okay. So now I've changed the color of the lines that I have drawn. Obviously I placed my protector over here, measured this angle to be 45 degrees. Then I placed my protector over here like this and measured a 45-degree angle. And since angle of incidence and angle of reflection are same, so after I drew this, I drew a line straight to this point. Okay, and then I made a normal to this mirror. Okay, and I kept my protector like this and measured this angle. It came out to be roughly 40. So I kept the protector in this way and measured the angle 40 as well, since angle of incidence and angle of reflection are equal. And then I drew this line according to my angle that came out to be 40 degrees. Okay, and it just goes to this point P. So obviously I didn't have a protector, so I had to keep my protector on the screen and draw these angles. So if you are doing it on the paper, it would be much more easier and convenient for you. But this is how it's going to be done. I've just given you an overview of how and where you are going to keep your protector to get this answer. Even if there are ambiguities, so you can always ask me in the comment section. Question number 20. The speed of light in the material is 50% of the speed of light in air. What is the refractive index of the material? When the speed of light and speed of material is involved, then our formula is speed of light in air by speed of light in medium So over here we know that the speed of light in air is 3 into 10 3 into 10 raised to the power 8 meter per second, and they've mentioned that in speed in the material the speed is 50% that of speed of light in air. So 50% would be divided by 2. Okay, so ये हो जाएगा, this is going to get cancelled, and the refractive index is going to be 2. So B is our correct answer. Question number 21. A beam of light is split into a spectrum of 7 colors. What is the name given to this process? This process is called dispersion of light. The splitting of light into its constituent colors is dispersion. Satellites are sometimes used to receive and retransmit television signals, which row shows the type of satellite and electromagnetic waves used. Okay, the type of satellite that is used to receive and retransmit television signals is a geostationary satellite, not a low orbit one. And electromagnetic waves that they use is microwaves. So D is going to be our correct answer. This topic has been recently added to your syllabus, and now I am seeing questions that are coming from it. So do this topic as well. Question number 23. A sound wave travels through the air and strikes a solid block of steel. Some of the sound is reflected from the steel and some is transmitted through steel. How does the speed and wavelength of the sound in steel compare to the speed and wavelength of the sound in air? So steel is solid, and obviously they are asking us to compare it with the speed of sound in air. We know that in air we usually take this value of speed of sound to be 340 meter per second, and in solid it is around 5000 meter per second. So obviously it would be greater in the solid, so speed in steel would be greater than in air, and wavelength in speed would also be greater than in air. So 23 ka answer is D, since V is equal to F lambda and speed and wavelength are directly proportional to one another. Question number 24. The diagram shows a bracelet containing two magnets. The arrow represents the pattern and the direction of the magnetic field due to magnets. Which row identifies the magnetic pole at J and the magnetic pole at K, where the magnetic field is the strongest? Acha, if you see this, so we always know that whenever we have a magnet, the magnetic field lines start from north and end at south. ठीक है? So like this and then this and this, ठीक है? And this and this. So over here they are coming in. So हमेशा they start from the north. So if you can see, so these points J and K are the points where they are originating from. So they must be north poles. ठीक है? And the magnetic field lines would be strongest at a spot which is closest to the magnet. So X is the spot which is closest to the magnet. So यहाँ पर the magnetic field lines are going to be strongest. So magnetic pole at J and K are north and north, and the magnetic field is strongest at X. So A is going to be our correct answer. Question number 25. Which row describes an electric field and its direction? Electric field is a point where an electric charge experiences a force. ठीक है? So a region in which an electric charge experiences a force, region in which an electric charge experiences a force. So these two are correct. And the direction of the electric field is the direction of the force on a positive charge. ठीक हो गया? So that is going to be A. Okay. Question number 26. Copper wire is available in fixed lengths but in various diameters D. Each wire has different resistance R. Which relationship between R and D is correct? R is directly proportional to D, R is directly proportional to D square, R is inversely proportional to D, and R is inversely proportional to D square. So resistivity is rho length over A, or it can also be written as A की जगह D square. So you can see over here that resistance and diameter square are inversely proportional to one another. So D is going to be our correct answer. Option which states that R is inversely proportional to D square. ठीक हो गया? Question number 27. The diagram shows three 20 ohm resistors R1, R2, R3 and the switch S connected to a DC power supply. Switch S is open. The potential difference across PD is PD across R3 is 9 volts. What is the PD across R3 when the switch is closed? Achha, if we just look at the circuit, so we see that this is a series circuit. Okay, and when the switch S is open, so what is going to happen? That the current is going to come in like this. Okay, and obviously it can't complete its circuit going into R1, so it is going to pass through R2, R3 and then go on. And if this switch is closed, then the current is going to come here, get divided, half of it goes here, half of it goes here. Then when it reaches this point, the current again unites and this happens to the circuit. Acha, now we need to know a few details regarding a series circuit. In a series circuit, I total is equal to I1 is equal to I2 is equal to I3. So the current in all the circuit is the same. And V total although is V1 plus V2 plus V3. Okay? So every resistor will have a different PD value. Okay? And although they are identical resistors. Okay? So first we have been given that the PD across R3 is 9 volts. Okay? So if there was a voltmeter over here, it would show 9. Okay? And what else do we know? That this is a 20 ohms resistor. So we can always find the current using these values. So we can find the current using this value. Okay? V over here is 9. I we need to find and resistance is 20. So 9 divided by 20 is going to give us 0.45 amperes as our current. So once we have the current, what we can do is now we have to find the PD across the whole circuit, okay, when the switch is closed. So what now we need to do is we need to find the resistance of these two resistors. Okay, so this is going to be 1 by 20 plus 1 by 20. So 2 over 20. Okay, and this is R T is going to be 1 minute, 1 by 10 say. So this is going to be 10 ohms. Now once we have our total resistance, this circuit is going to now be like this. Okay, so 10 ohm resistance is over here and 20 ohm resistance is over here. So now V total is going to be I total into R total. So V total is equal to I total is equal to 0.45 since it's the same for all the circuit, and R total is 30. So 30 into 0.45 is going to give us an answer of 13.5. So it resembles this answer. So C is going to be our correct option for this. Okay. This question number 28. The circuits shown all include a DC power supply, one diode, two light emitting diodes. In which circuit will both LEDs be turned on? If we look at our first circuit, and by the way, we know that diode is something that allows current to move in one direction. Okay? It basically converts AC to DC current. Okay? So over here, this might start from positive, this might start from positive, but this is not going to, the circuit is not going to be completed because diode has asked this current to go back. Okay. As far as B is concerned, the current is going to start from here, go like here, and when it reaches over here, so it is asked to go back. So the circuit is never going to get completed. So this is wrong as well. Okay, looking at C, the current starts from here, goes here, then goes here, and the circuit gets completed. So C is going to be our correct option. Yahan se when the current is going to start, so it has to move back. The direction has to change, so the circuit is never going to get completed. So this is wrong as well. Question number 29. A wire connected to a resistor R is moved in a magnetic field. A current is induced in the direction shown. In which direction is the wire moved? Okay, we are talking about induced current over here. So we know that whenever there is a mention of induced current, we use our right hand Fleming's rule as opposed to Fleming's left hand rule. Okay, so over here we know that our first finger points towards the magnetic field, the second finger points towards the current, and our thumb basically shows the force. So if we now place our hand like this, okay, first finger is pointed towards right, the current is pointing towards us, so the force is going to be pointing downwards. So our magnetic field first finger is pointing like this, the finger of the current is towards us, and the thumb is pointing in the downward direction. So C is the correct option. This is the direction in which the wire is going to move. Okay. Question number 30. Which component is not found in an AC generator? Okay. A. Coil of wire. It is found in AC generator. Split ring commutator. Yes, this is not found because it is found in DC motor. Okay. And magnetic poles have to be there because induced current has to be created, and without magnetic poles it can't be created, and slip rings are found in AC generator. So B is going to be the correct option. Moving on to question number 31. There is a current in straight metal wire in the direction as shown. Which row describes the direction and the pattern of the magnetic field due to the wire when looking from vertically above the wire? Okay, whenever we have a conductor like a wire, so in order to find the direction of the current or the magnetic field lines, one is given and one that we have to find. So we always use our right hand grip rule. So in right hand grip rule, our thumb points towards the direction of the current, and the curling of the fingers basically gives the direction of pattern of magnetic field. ठीक हो गया. So if the direction of the current is upwards, so if we just curl our fingers like this and point our thumb like this, so our fingers are going to curl in an anti-clockwise manner. ठीक है? So the direction of the magnetic field lines is in the anti-clockwise direction, and the pattern always is circular. Okay, it's never parallel lines, it's circular. So A is going to be our correct option for it. Moving on to question number 32. A simple transformer contains an iron ore. What is the function of the iron ore of the transformer? Basically, its function is to link the magnetic field in the primary coil to the secondary coil. So A, to conduct current from the primary coil to the secondary coil. नहीं जी, this is not correct. This is not its function to enable the secondary coil to act as an electromagnet. No, this is not correct. To ensure there is a high voltage between the primary coil and the secondary coil. nahi ji, because a transformer is used to either step up or step down the voltage. So this is not its function. D, to link the magnetic field in the primary coil to the secondary coil. Yes, this is the function of the iron core in a transformer. So D is our correct option. Okay. Question number 33. In an alpha particle scattering experiment, a beam of alpha particles is fired at a very thin piece of gold foil. In which direction do most of the particles travel after hitting the foil? Most of the particles are going to pass through undeviated. So A is going to be our answer, and the reason for it is that most of the atom is empty space. ठीक है, so most pass through clearly, some are deflected backwards. This is due to the fact that the charge is concentrated in the nucleus, and then there are these deflections as well which have a reason, but they've not asked us, so let's move on. Question number 34. An atom of boron contains 5 protons, 5 electrons. The nucleon number of the atom is 11. How many neutrons are there in the atom? Okay, there are 5 protons and 5 electrons, and the nucleon number is 11. So if we subtract protons from the nucleon number, so this is going to give us the number of neutrons. So 11 minus 5 is going to be 6. ठीक हो गया? So there are 6 neutrons. Moving on to question number 35. A detector placed near a radioactive isotope gives a measured count rate of 800 counts per minute. The half-life of the isotope is 3 hours. The background count rate is 32 counts per minute. What is the count rate on the detector after 6 hours? अच्छा जी, whenever we are given count rate, ठीक है, when a detector is placed near radioactive isotope and we are given the background count rate as well. So the first thing that has to be done is that the background count rate has to be subtracted from the count rate when the detector is placed near the radioactive isotope, so that we can see that what is the actual count rate of this radioactive isotope, and the background radiation background count has to be taken from it. So 800 minus 32 is going to give us 768. So this is the reading due to the radioactive isotope and not the background count included. See, we have 768. So what happens is that the half-life is 3 hours. So after 3 hours pass, one half-life pass, 3 hours, and one half-life passes, this count is going to be reduced to half. So 768 is going to be reduced to 384 counts per minute. After another half-life passes, yani another 3 hours and 2 half-lives, this is going to be 1/4 of this. So 384 divided by 2 is going to give us 192. ठीक है, and they've asked us that what is the count rate on the detector after 6 hours. So it is going to be 192, but obviously we also have to add in this background count rate again. So 192 plus 32 is going to give us a count rate of 224 counts per minute. So many students ask me, why do we have to first subtract the count rate and then add it back? If it has to be added back, so why is it taken out in the first place? So see, when we've taken it out, followed the half-life pattern, so the answer is very different. And if we don't take it out, we take it as 800, so 3 hours की half-life के बाद it's going to be divided by 2 and it's going to be 400. And after another in the 3 hours past, so after 6 hours it's going to be 200 counts per minute, which is not the correct answer. Okay, so if you don't take it out first and add it later, so you are not going to get the right answer. So whenever you are shown a count rate of certain count rate due to a radioactive isotope, and you are given the background count rate, so the first step has to take this background count rate out of this count rate, and then take out the half-life in calculation, and then when you have the answer to add it back as well. This is the third step. Then only you are going to get the correct answer. Okay, if you have any problems related to it, there are all the past paper questions solved under the topic of radioisotopes and radioactivity, so kindly go and see those videos and you'll have a clear-cut idea. Okay, question number 36. Sodium-24 is a radioactive isotope that emits beta radiation. Okay, which nuclear equation shows how sodium-24 decays? Okay, whenever there is a beta emission, so the nucleon number stays the same. Okay, and the proton number increases by 1. Okay. So we'll see where this thing happens. So the nucleon number has to stay 24. So there it is 24, here it is 24, here 11 is gone to 12. Yes, and one beta emission takes place. So A is going to be our correct option. Okay, the nucleon number remains the same and the proton number gets increased by 1. Over here the proton number gets decreased by 1. Over here यहाँ पे तो अल्फा emission हो गई है, so this is not correct. Over here 24, 11, 20, यहाँ पे भी ऐसा ही हो गया, so this is not going to work. A is the correct answer. ठीक है. Question number 37. Which safety precautions must be taken when using a source of gamma radiations? Reduce the distance between the source and the person. This doesn't help with anything. Reduce the time of exposure to the radiation. Yes. Use a suitable shielding material between the source and the person. Yes. This is also correct. So 37 ka answer would be D, 2 and 3 only. Okay, moving on to question number 38. A student defines 3 periods of time. The time Ts taken for the Earth to orbit the Sun, the time Tr taken for the Earth to rotate once on its axis, the time Tm taken for the Moon to orbit the Earth. Which row shows the shortest period of time and the longest period of time? Okay, the time Ts, which is the time taken for the Earth to orbit around the Sun, it is 365 days or 1 year. The time Tr taken for the Earth to rotate on its once on its axis is 1 day, 24 hours. The time Tm taken for the Moon to orbit the Earth is 1 month. So the shortest period of time would be Tr and the longest would be Ts. Shortest is Tr, longest is Ts. So B is going to be our correct option. Question number 39. Which statement about the universe is correct? The universe consists of 100,000 galaxies. Redshift is a decrease in the observed wavelength of electromagnetic radiation emitted from the receding galaxies. C. Light emitted from distant galaxies appear redshifted. D. Redshift of the light from the galaxies, distant galaxies gives evidence that the universe is contracting. Okay. Now, first let me state what the correct answer over here is. It is C. Light emitted from distant galleries appear redshifted. And why the answers are not A, B, and D? Because they have given us a finite number that we have 100,000 galaxies. We don't have a finite number. We don't have a number that we can put up to the galaxies. They may be unlimited galaxies around. So that is why A is not correct. अच्छा B जो है वो क्यों है not correct. They say that redshift is a decrease in the observed wavelength of electromagnetic radiation emitted from the receding galaxies. Basically, redshift is not the decrease, it is the increase in the wavelength. So this is not correct because of this fact. And D states that redshift of the light from distant galaxies gives evidence that the universe is contracting. The redshift of light from distant galaxies provides evidence that universe is expanding. ठीक है? It's not contracting. So that is why this is not correct and C is our correct option. ठीक है? Because, acha, why do we take C as our correct option? Because light emitted from the distant galaxies appear redshifted. This is true. Okay. Question number 40. Which statement about the cosmic microwave background radiation CMBR is correct? A. CMBR now has a frequency higher than that of the infrared. CMBR has always had exactly the same frequency. CMBR has a shorter wavelength in the past. CMBR was produced a long time after the universe was formed. Okay, 40 ka answer is C. And now let's look at the options that why A, B and D are not correct. CMBR has a frequency higher than, nahi ji, CMBR has a lower frequency than the infrared radiation. You know that ठीक है, so infra is after microwaves. ठीक है, so the frequency increases as you sorry, this is wavelength. Frequency increases as you go towards the right. ठीक है, so that is why this is not correct. CMBR has always had exactly the same frequency. No, the frequency of the CMBR has decreased as the universe has expanded. So there is a decrease in the frequency and it is not exactly the same. ठीक है. अच्छा, D कहता है कि CMBR was produced a long time after the universe was formed. तो CMBR was produced relatively early in history of universe, approximately 380,000 years after the Big Bang. So it was not produced after a long time, it was produced relatively early. So this is not correct. And why have we taken the C answer to be correct, which states that CMBR has a shorter wavelength, had a shorter wavelength in the past? Because CMBR is basically the leftover radiation from the Big Bang. ठीक है. And as the universe cooled and expanded, radiation was redshifted to longer microwave wavelength that we see today. So in the past, the wavelength was shorter. Okay? So that is why we have taken it to be correct. So this brings us to the end of this paper. I hope my explanation and the solutions that I've provided have cleared your questions and ambiguities. So kindly like and subscribe the channel so that you don't miss any video. And best of luck for your exams. Allah Hafiz.